Alright, this is test 3 review, and this is subtraction with borrowing. So I'm doing 20 and 21. So we decide, are there common denominators? That's the first thing we have to look at. And in this case there are. And the next thing to look at is, can you subtract 6 from 3, which you can't. What is required is to borrow from the whole number. And how that works is, if you have 20 circles, and I'm not going to draw all 20, but if you can imagine 20 circles drawn, it's like taking one of those circles, removing it from the others, and cutting it into pieces. So that essentially it's a whole cut into pieces, and I've mentioned this on another video I did. In this case, if we cut this whole piece up into 8 pieces, it then equals, as a fraction, 8/8, which we know any number over itself equals 1. So if you can imagine 20 circles, and we're going to take one of those circles out and make it 19 circles, and we still have this one sitting here ready for us to cut it into pieces. Well, what would make sense? Would it make sense to cut it into 4 pieces and then you have 4/4? Not really, because what you'd have to do is add that one piece to this fraction. And why would you want to add 4/4 to 3/7? You wouldn't. It's too complicated. So the idea is to cut the whole piece that you're borrowing from the whole number into pieces that you can add to this fraction and then subtract from this fraction. So we have to create that whole piece to have a denominator of 7. So how many pieces do we cut it into? We cut it into 7 pieces. It's really that simple. And while I can't really draw that very well on a circle, that's the fraction that we borrowed to make 19 pieces left, and we're going to add that to 3/7 to make our new fraction, which will then equal 10/7. So we will have our new little fraction that we made. It will be 10, 19, and 10/7. Now when you look at this, because we added a whole piece to this fraction, you're going to notice this is an improper fraction. It should be. You should be able to get a whole piece out of it really quickly if we went 7 into 10 and we subtracted and got 3, we'd have 1 3/7, which is telling us that 7/10 is made up of one whole piece plus 3/7, and that's what we did. We took one whole piece, cut it into 7 pieces, and added it to this fraction. Alright, a lot of explanation for a little bit. So we take this number, lower it by 1, and we add however much the denominator is to the numerator, and that will give us the new numerator of 10/7. That's sort of a shortcut. You could say subtract 1 from here, add these numbers, and put it on top. But it's good to know what we did. So now that you have 19, you can subtract 0 from 19. That's okay. This is a 0 here, and we have 6/7. You don't have to put a 0 there. I'm just showing you that when you have no fraction down below, that's okay. So if we subtract, 10 minus 6 is 4/7, and 19 minus 0 is 19. So, alright, number 21, we have to ask ourselves, are there common denominators? And they're not. So we have to do that first. So we take the larger number, 25, and we do our multiples. 25 times 1 equals 25, does 20, and we ask ourselves, Does 20 go into 25? No, so we go to the next multiple of 25. Times 2 equals 50. Does 20 go into 50? No. So we're looking for a multiple that both 20 and 25 will go into. 25 times 3 is 75. 25 times 3 equals 75, and you say, does 20 go into 75? No. I'm sure there's some of you already figured this out, but I'm going through the process just in case there's anybody still unsure about what's the best way to approach this. So 25 times 4 is 100. Now 20 does go into 100, so we found a least common multiple. So that's what we need to change our denominator into. And that means that in order to change 25 to 100, we multiply by 4, which means we multiply the numerator by the same number to make the equivalent fraction. 20 has to be multiplied by 5 to get 100, and so then the numerator is multiplied by 5. So our new fractions, and we haven't even gotten to whether there's borrowing yet, our new fractions will be, we haven't touched the whole number, that's still the same, 28, 7 times 4 is 28, over 100. Because 25 times 4 is 100, it's like 4 quarters. And the 9 is not touched, and then we have 35 over 100. Okay, so we're like, oh good, we got that out of the way. However, can you subtract 35 from 28? You can't. So you have to do another step, and that is to borrow. And in this case, just like up here, what we're doing, and I'll use a different color, we're taking a whole piece out of this. Here's the whole piece. We bring down this number by 1. What's the cheater's way? Just add 100 plus the 28, and you have a new fraction of 128 over 100. Remember to use the same denominator. What we did is we took one piece out and we cut it into 100 pieces, which I am not going to do that, but let's just pretend. So then it creates a fraction of 100 pieces out of 100 pieces, and any number over itself equals 1. So one whole piece was taken away from there and cut into 100 pieces, and then added back to this fraction over here. So let me write that in just like I wrote it up here. 100 100ths is then added to 28 100ths, which is how we got the 128 over 100, the improper fraction that includes this whole piece that we stole out of that whole number. Okay, so this stays the same, this didn't change. So this is a borrowing step up here, and this is just dragging it on over to the right so we can continue working on our problem. Now we have 128 minus 35. We can do that. And that will be 3. 12 minus 3 is 9. It'll be 93 over 100. Squeezing it in. 16 minus 9 is 7. So 7 plus 9 is 16. So 7 and 93 hundredths. And this is already reduced. Now let me circle that as our answer. 7 and 93 hundredths is our answer for number 21. I'm going to do more borrowing on 22 and 23.